And right now I'm starting the session here. So my voice is audible. Am I
Yes,
audible to you? Okay.
yes,
Okay. Screen is visible.
yes.
Okay. So today, as director sir already told you, there are many lectures, and yes, before 2 or 3 days is going on continuously, and some of the persons experts are delivered the talk on information security, machine learning, and now I'm delivering the talk on big data analytics and map reduce. So you will see in this what is the big data analytics and how this big data analytics basically incorporate by the MapReduce and whatever the MapReduce basically functionality. And we will see the Hadoop version 1, version 2, brief description of version 1, version 2, and the MapReduce, how the MapReduce is basically are working. Some of the participant also already know the basic of MapReduce, but we'll see the actually the what will be behind in the systems. Okay, and so outline of today presentation, today expert talk, starting from the big data introduction, then we will go for the Hadoop version 1, version 2 description, and then we will move forward to MapReduce, and finally some research direction in MapReduce I will introduce here. So this is the use case of big data analytics, because everything is basically right now is connected by the overall we are connecting with the internet. And as we can say right now we having in the era of data. Okay, in that means whatever we are using, like in this diagram you can see here, that is central part is basically looking at big data ecosystems. We will see what this big data ecosystems are. So generally, you can say that this is the component in which the data processing will be going on. So that is called the big data ecosystems. There are many things involved for storage, for execution, or for processing. So there are maybe some tools, some software maybe having this big data ecosystem. We will see these things in after a few slides. So you can see here that is big data ecosystem is incorporate totally covered by the some other application whatever we are using right now. So like you can see here, that is mobile phone we are using. So we are using mobile, and in mobile we are storing some informations like photographs, video, and maybe we are using for the social networking also. Same way location data and machine data is also be incorporated. Like location data means what, where, whenever we are going from one to another location. So that means our data is capturing by the satellite systems, and this information is also stored for some duration, or maybe for transferring to one end to another end also. Machine data we have, like whatever the machine we have connected, like the we can talk about the satellite simply. If we want to transfer some information from satellite to remote station to another remote stations, so we required the that type of data. So that is machine data we have. Whatever the system data we have right now, I'm using my laptop, this is also machine, so it having the some data, and we are incorporating this data to transferring to another end. Okay, so this overall this complete architecture is, we can say that the completely covered with the four things you can see here, that is volume. So volume we are talking about the larger the amount. Okay, so that means amount is very huge, you can see here. So like this, that is one figure is also given here, that is decade of digital universe growth. So you can see here that is very small is thing is given, that is 2005 130 around growth was there, and 2010 that is 1002 and 2018 that is 7910 around. So you can see that is increasing year by year, you can see. But right now that is increasing day by day. Means this growth is increasing very fast amount. So volume is very large, and this is volume is generating by the all these applications. Okay. Now you can see here that is velocity. Velocity we are talking about the means the speed in which the data is coming. That is very fast speed. You can see here that if we want to analysis these type of data within a duration, otherwise we are not able to see what data will be contain some useful information, because after some time this data may be pass away and new data will be there. So what is this? This is the called the streaming. Okay, that means this is the stream data, means very high speed is coming, speedily is coming, and after you can see after few minutes that will be means going away. Okay, so we need to analysis these data within a time, like Twitter data we have. Okay, so tweets whatever we are coming, so they are continuously is basically increasing, and after you want to analysis these Twitter tweets, so you need to analysis in a particular one at a time. Okay, so this is the velocity. And this click stream data, this is also streaming data is coming. Click stream continuously browsers searching data is coming, and it may be chances some after sometimes it may be deleted because the streaming is very fast. So there are very streaming data, there are various type of streaming data, and you can see that is point of sale is one streaming data. SMS is one of form of streaming data, you can see here. And whenever we can go for the value. Okay, value is basically whenever we are talking about the value means it contain the cost. Okay, means business perspective we are talking about. So what do you mean by values here? If that data is some cost or not. So that is means business perspective. Business is always talking about in the price and money. So whatever data is generating, it may be some delivering the cost, incorporating the cost, and this will be used for business purpose. Okay, means that recommendation may be provided. If suppose that will be used for recommendation purpose, if that will be used for some stock market purpose. So there are various types of data, and sometimes it is useful and sometimes it's not useful. So it may be depending upon the whatever the cost of data is basically there are some mechanism for calculating this cost also. So this is social networking. Sensor data is basically the covering the this era. Okay, and the cost whenever we are talking about that is ERP, RFID. This is basically our connecting with this value also. Variety, you can see here that is variety means that is various types of data is coming. Various types of data means it may be structured. Means structured means that maybe contain the one form, means in which we can say that yes, like our library management system, that may be contain the some specific details, specific fields. So that is a structured data. Unstructured data, that is not in fit into the one form, we can say, or it may be there are various form is basically are coming, and that is not we cannot able to convert into the one appropriate format. So that is unstructured data. So we need to handle these type of data, unstructured and structured, as well as there are another type that is in between structured and unstructured, that is semi-structured data. Okay, so semi-structured data is basically contain the both things of property, so that will known as a semi-structured. So this is a big data analytics, and big data analytics we there is one difference between analysis and analytics. Whenever we are talking about the analytics, so we are talking about the future. Okay, means whatever the future we need to predict. Okay, and analysis we are talking about the past. Okay, so that means we need to some future data and we need to some analysis on the some predictions. So we use the analytics words, and analysis basically are we are reading the past. Okay, so there are big difference, and that is when sometimes it may be using interchangeably, and this is a basically use case of big data analytics. Right now you can see here we are what is the basically the big data is. So the amount of data is very coming very fast. So right now in one hard disk you can see here, 1 terabyte of hard drive that holds the 260,000 songs. Okay, 1 terabyte of hard disk. And whenever we are talking about the some around 2005 2006, so we have around the small PCs like 50, 40 to 80 GB memory is sufficient. Right now we are having 2 terabyte laptop or desktop. So you can see here that means our data is increasing and nobody is deleting the data. Old data is retained itself and nobody is deleting this data. So that means you can see here that is huge amount of data we are holding continuously from the past and now in future also. So 20 terabytes of maybe store the photo uploaded to Facebook each month. So you can see here that is it is a very huge amount. Okay. This is a 120 terabyte, all the data and images collected by the Hubble Space Telescope. So this is very huge amount. That so all basically are talking about the amount of data is very vast. Okay. So 1 petabyte, that is you can see here data processed by the Google server. So every 72 minutes. So you can see here that is 1 petabyte is 10 to the power 15. So you can see here that means that is continuously is increasing, and that is very fast amount. So we need some processing as well as the fast processing of these data and storing of these data, processing of these data. We need some new technology. That's why. Okay. So digital universe growth. You can see here that is. You can see here that is from we already talked in previous things, so that is increasing by year. So you can see here that is 130 zettabyte is basically extra byte, and it will be increased to 2012 is 1.2 zettabyte, and right now that is 220. We are talking about 2020, so that is 35 zettabyte around. It may be approximately much more. Okay, so that means the growth of data is increasing year by year, and that means in sometimes after we can say that will be increasing to more amount. Okay, we are not able to calculate even. So, that is some definition of big data. That is most common associated myth with the big data is we are talking about the volume that is already explained, and but big data is basically referred to the 5 V's, means 4 V's we have already seen. So if data contain the volume, velocity, variety, okay, value, okay, and variety and veracity. So this basically are the big data, and we can say that big data is information assets, and today is basically we are taking the decision on the basis of the data driven. So the 5 big data is 5 V is basically defining the big data. If suppose any data having these 5 characteristics, so we can say that this is the big data. Okay, or 3 at least. First 3 is defined, after sometimes after few years the 5 V is basically defined. So that is volume, that is we have already know, that is talking about the amount of data. Variety, type of data, we have already know that. Velocity, at the speed which data is coming, and veracity, the degree which big data can be trusted. Okay, so and value, that is cost. Okay, so that is the overall big data in which particularly 5 V's are there. So we can say that this is the big data. So right now this is in this figure you can see here that is we are changing with the year by year technology. In previously in 1968 around, We have OLTP model. There is online transaction processing. Online transaction processing basically uh, used for the hierarchical database and relational database. And this is the calculation is basically done by the optional database. And all these figures basically incorporate the data set into the rest position. Okay. So that means there are some human analysis basically done by the on the historical data, and that will be uh, in basically displaying on the systems. Okay. Now from the that is very old online transaction is very old scenario, and OLAP is an online analytical processing. This one is an recently we have seen in around 10 years for right now we are already using this, but right now that is in terms of the high speed, that is old one. But OLAP is online analytical processing, in which basically we are depending upon the data warehouse, and whatever the past data, we are analyzing this data for future, predicting the future outcomes of particular product. Okay. So that the this goal of this online analytical processing is basically you need to increase the business outcomes. Okay. So this is the data and rest positions. Okay. And finally, whenever we are talking about the motion, means data is continuously motion going on from one tunnel, we can say that. And one tunnel, that means data is inserting, and between these tunnel we need to analysis this data. Whenever this is out from this tunnel, so we can say that yes, this that there is no way to analysis. So between this tunnel we need to analysis this data, or use some information processing, and then we can say that yes, this is the result. So data is motion, basically talking about the real time analytics, and real time analytics means uh, for in between this duration we need to analyze the data. So we need some old techniques as well as, but we need to incorporate the some new techniques. Okay. And we need to club these old and new techniques and using them in the new scenario. So that is right now is the stream computing, we can say that is real time analytics is the stream computing. Okay. How big data is generated? So we have already seen that that is social media networks, scientific instruments. This is the main area in which the big data is continuously generating. If you are going to point of sale, even everybody having the mobile phone right now, 64 to minimum 64 GB storage. Okay, even you can increase the 128 around. Okay, so that is means the data is continuously increasing, and we are posting. Everyone is right now in social media. Okay, means Instagram, Twitter, Facebook. So everyone is on the social media and increasing the vast amount of data. So this is the data is generating from the these scenario, and this is a many more possible direction also be there for generating this data. This is not limited. How big data can be handled? So this is the main area, because we know that right now in previous slide we are right now able to know that yes, this data is basically generating a very fast amount, velocity, volume, very these characteristics is storing. But question is this, means how you will handle this data, and can we able to handle this data, or there are some incorporate some new technology. So in previously before to handling this data, there are distributed computing is there, and there are some issues with these distributing computing. So the basic one problem is was there is means, if suppose you need to compute, you need to start your computations, so you need to move your data to computation power. Okay. So in this, big data is basically solve this problem, and big data is saying that you don't need to move your data from one to another. That will be maybe cost very much. So in this case, you need to where whenever your data is basically residing. So you can use this data for calculation at particular this place. Instead of moving data, you need to moving your computing. So this basically defined by the Hadoop. So Hadoop is mostly used in open source tool for handling the big data. So we can say that Hadoop is a pillar in which we can say that this big data will be using for handling for many more purposes. So we can say that this big data is basically is a base. Hadoop is a base in which we can use this big data. And how this Hadoop works? So Hadoop is basically other distributed storage and parallel computing scenario. And this distributed storage means you can store your data in somewhere into distributed part, one into the blocks forms, we can say. So that one block store you can store in one location, another block you can store in other locations. And parallel computing means where whenever your data is stored, so you can start your computation where the data is basically located. Okay, so that is the Hadoop working. Hadoop distributed file system used for distributed storage, and for handling this MapReduce is framework, and for handling this type of computations, we use the MapReduce, and this MapReduce is a framework for that is used for parallel computations. Okay. So you can see here that is Hadoop version 1. Hadoop is a framework used for scalable processing of data. And we have already know that scalable processing means increasing time by time. If suppose right now we having the zettabyte of data, and in future suppose petabyte of data is increasing. So yes, Hadoop is a functionality in which data is scalable. So we can use this as the data is increasing as okay. So that Hadoop is consists of HDFS, that is distributed file system, and this is the MapReduce. We have already told you in previous slide. And this MapReduce basically is a, we can say that is a core of HDFS, which is the we can say that execution engine. Okay, and execution engine means that basically MapReduce is basically used for scheduling the task on HDFS. Okay, and this Hadoop version 1 basically is a first version in which basically some limitations of these version. We will see these limitations. So Hadoop version 1 is basically first defined, and this MapReduce concept is first defined by the Google, as you know that, and this is the patent by the Google. So this is the same thing is used right now. We are using Hadoop version 1 as well as for some scenario, and whenever we are having some limitations, so we can use for both versions. So right now Hadoop version 1 is using, and Hadoop version 2 is also using. So for the distributed and for the moving for some this direction, we need to incorporate in Hadoop version 1. Whenever the Hadoop version we are talking about, so why we need to combine the storage and execution in one scenario. Okay, so means execution is basically Hadoop version solve this problem, that execution we are talking about the data locality. So data locality is we need not to move our data to one location to other location. Okay. So that means very cost is very effective. Suppose that is 1 terabyte of data we need to transfer. So that means you can see that is very vast amount of data will be transferred from one location to another location, and that maybe introduce some error. So that's instance of this, we can use the computational power where the data is residing. Okay. So this combined storage and execution moves compute towards the data, not big data towards the compute. Okay, so we are moving our compute here and not the data. Okay, so Hadoop HDFS basically whatever the goal of this HDFS is basically is reliable storage of commodity of shelf hardware. So commodity of shelf hardware is basically using for the business purpose, that is vast amount, and that is means pay as much you can use. So whatever the requirement you can use, whatever the pay, and you can use for as per your requirement. So that means that is Hadoop distributed file system basically reliable on the storage, and this is just implemented in Java. And so security purpose is Hadoop is right now secure, but there are some issues in security. But right now we are not talking about this security issue, but we can talk easily, that is as much as the previous one right now, that is security is very much fast. And provide a single writer multiple reader concurrency model, means only one writing is allowed in one at a time, and that time multiples wants to read this data, so it may be allow the multiple one to read. Okay, so this is the HDFS, and that is maximum capacity scalability is 200 petabytes of storage, so that is very larger amount, and that is 4500 servers basically you can connect with this. Okay, so this is the HDFS scenario. So features, whatever the old feature is incorporated in this, always in this new as well as, and there are some new features basically introduced by the HDFS, that is hierarchical namespace. So hierarchical namespace means there are whatever namespace you can create into the hierarchical form, one in low form, in tree form you can say it, and the ACL permission, read write. Moving permissions. So whatever the Unix ACL permission is basically incorporated as it is. Second feature is high availability and automatic recovery. High availability means that is all time is available. 24 cross, we can say that 7 is available. And you need not to be worried about this availability of Hadoop. Automatic recovery means whenever the data is lost, or suppose that in any scenario your system is not working, so it may be there are some other portion of availability is there, and you can use this availability and transfer or processing your whatever you need to compute. Okay, replication of data. So replication is basically in previous scenario, and suppose that due to some error that one whatever the data moving from one to another location, and during this moving, suppose that it may be corrupted or lost. So that move out means that data is moved from one location, so that is this location also not having this data, and the receiving also not having this data, so that means that may be lost of data. So right now Hadoop solve this problem and introduce this replication of data. And replication of data means that data is stored into the one or two more form due to the any loss. Suppose that data is connectivity is lost from one location, so that may be data is stored into the another location also. Okay, so you can access your data from another locations. Rake awareness, very important things. Rake awareness algorithm, basically the performance and high availability. Rake awareness means your data is maybe stored into the racks, and this is stored into the data nodes, and this data node is handling your data. Okay, so that all data, you cannot store all data into the one rack, so it may be stored into one or two or three racks. Okay, so that may be providing the high availability. Due to the loss, you can access your data. Same things in the replication, and same thing is rake awareness. Parallel file access means one, if suppose that your data is stored into the blocks and you need to access all blocks, so you can access these all blocks by the parallel access of all racks. Okay, whatever the data nodes is stored, so you can access these all files parallelly without any hesitation. Next is, you can see here, that is architecture wise. So HDFS architecture is basically is metadata, and you can see here that is one is name node is there. So we can say that is name node is basically, this name node is basically, 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 name node is basic This name node is basically is the master. Okay. And master having the capability to checking the all the whatever the data nodes that is connected with this. So all other things are the slaves, and this is the name node is a master, and data nodes are the slaves right now. So suppose that in this diagram, in client want to write anything. Okay. So client want to, there are two racks. This is a one rack. Rack means that is, you can see here that is, we can say that this is one location like in your college, GITM, and this rack is another location. This is our MNIT right now, suppose that. And this is a client and they are want to write some data. Okay. So write particular data. So first client want to request from the name node. He want to write some data. Okay. Name node will be answer this. Yes, you can write the data from. Suppose that this is D2, okay, and this is D5. Suppose so you can write now D2 and D5. So this address will be provided by the name node, and then client writing the data on this one and this one. Okay, both node. And automatically whenever the data will be right, so from data node will be created some replications. Okay, so replication means that replica will be stored some another rack also, same rack that will not be stored on the same rack, it will be stored on the another rack. Suppose that in due to the some reason that is GITM is not working. Okay, this rack GITM is not working, so our MNIT is able to fetch this data. Means client will able to fetch this data from the this rack. Okay, so this racks is basically is different computing power, different storing power. So we will see these things. And if suppose that second thing is, first is writing, second thing is client want to read some data. So reading of data, so client say that from the name node I want to read my data. Okay, so that suppose that ABC data is want to read. So name node provide the latest connectivity. What do you mean by why this client is asking why the name node? Because client doesn't know that it means connecting this current recs are presenting or connecting with the easily or not, where this data is maybe located. So name node is having the all information of these data. We will see how this basically handling this data. And name node answering this thing, yes, your data is will stored into the rack one on this D1, suppose. So you can read this data from this one. So name node having the metadata, that is metadata is basically the data is very name, replicas are there. Okay. So all these things are basically is incorporated by the Hadoop architecture. So this Hadoop architecture is basically is same and version 1 and version 2 there are some changes we will see. And this is the small things you can see here, that is data nodes contain the small green one. This is called the blocks. So data should be stored into the blocks. Okay, data should be stored into the blocks in the Hadoop architecture. So you can see here that is high level architecture, that is distributed. One form is distributed data processing. Another we have distributed data storage. So we have already seen that. So that they are the basically from this figure we want to explain the where is the MapReduce task start. So you can see here that is means the client having these two functionality, and this whenever we are talking about the right part, that is data storage, so that is HDFS. So HDFS basically is incorporating the master node, name node, and it is also creating the secondary name node. So suppose due to that this name node is failed, so this is the secondary name node will be take care of these tasks. Okay, so all the information will be stored in the HDFS, and this is called the masters, and this is for the storage purpose. Okay, and distributed data processing is tasked by the MapReduce. So MapReduce is basically use the for the calculation purpose how this data will be processed, and And this MapReduce is basically having some functionality. We will see the MapReduce functionally. Basically, that is some mapper and reducer task is there. So there are some mapping tasks and some reducing sound tasks. We will see how these will be work. And there are some job tracker. Okay, so MapReduce having the job tracker, and job tracker functionality is tracking the jobs and how many data nodes basically that is connecting. Okay, so job tracker is basically tracking the how many tasks basically going on with particular data informations. So job tracker and tracking the jobs with the task tracker. Okay, and name node is connecting with the data node here. Okay, so this is the slaves. Below part are the slaves. This is the means level wise architecture. You can see here there is level wise architecture for more explanation. And the slaves is basically are the contain the data nodes and the task tracker. Okay. So this is the overall explanation of whatever we have seen in the previous diagram. That is name node is central manager of file system namespace. Central node, this is master node. So file name permission basically incorporate in this. Whatever the file name is stored, whatever the permission in file name is basically reading, writing, removing, deleting is maybe there. So name node is contain this information about the blocks location wise, where the MNIT, where's the GITM, where's the suppose NIT Raipur. So that all the information will be stored here. And this secondary name node is basically used for the backup data. Okay, backup for the data. Suppose due to any loss, the name node we are not working. So our data may be available on the secondary name node. Data node is, as we have seen in this, that is provide the storage of objects, and this is basically connecting. Means data node is basically creating the replications. Okay, means whenever that having the some data will be having the stored, so that will automatically create the replicate of this data to another rack. Okay, and this information pass away to the name node. Okay. So task tracker, another task is task tracker, and this tracker a very important part, and this basically use for the purpose of tracking the whatever the map, how this map reduce is working. So that is means accepting and running the map, reduce and shuffle. So there are in map reduce there are three tasks. So map task, okay, reduce, shuffle and reduce. Shuffle sort is there and reduce is there. So shuffle sort is working in one transaction. That's why we are saying that this is the three tasks. So that is map, shuffle, sort, and reduce. So task tracker is basically use the logical calculation of CPU. That means, what do you mean by logical here? Logical means how that task is stored in the CPU, and means how many slots basically required for handling this number of tasks. This tell by the task tracker. Okay, and task tracker is basically used for used for the schedule the task. Okay, and for machine holding this particular data. So task tracker is very much helpful for fetching the logical of address of particular CPU for storing and provide the number of slots for this particular task. So all these functionality of task tracker will be run on the same rack. Okay. Next is job tracker. We have already seen that is basically the management of. We can say that this is the main core management or central management of MapReduce jobs. Okay, and there are secondary job tracker for backup the data also. Okay. So you can see here that is system level wise architecture. In system level wise, we can see here that is means there are multiple switches are there, and this is means our suppose this we are connecting with this Hadoop cluster, and there are switches basically incorporated there, and switch will be incorporated for another switches, and this address will be holding the switches. So how this is basically connecting. And this switch will be having the name node, job tracker, secondary name node, and that may be connecting with the one client, and this client also having the data node and task tracker. So you can see here name node having the data node and task tracker, job tracker is handling with the data node and task tracker. So that is basically all the RX. So this is the physical system level wise architecture in which all the data will be stored into the switch wise and connecting with the switch wise. So SDF is read write operation. So files basically, as I already told you, that is means stored into the block. Okay, split into the blocks. So if that is means, suppose that your file size is right now, suppose we can say that 1 GB. So it will be divided into parts. Okay, so it may be divided into 64 blocks, 128 to 56 blocks, and this block will be stored into the racks. Okay, and automatically that data node will be create the replicas. So blocks basically are distributed in the all the over the nodes. Okay, over the all nodes that blocks will be distributed. Okay, suppose that we are running, we can take one example here. Suppose that we need to apply one word count application. We want to run word count application. That is a very basic application of MapReduce or Hadoop. We need to count how many words in particular file, that is, okay, means how many words that is appearing into particular file. Or so our data will be divided into the parts. Okay, and this data will be fetched by the name node whenever that is particularly processed by the MapReduce. All the functionality means mapper is will be mapped this task from the key value pairs, and then key value pairs will be using this task for another shuffle and sort. Okay, merging the whatever the repetitions, and finally will be having the reducer will be reduce this to providing the final result. So reducer will be finally providing this, incorporate all the results, generating the final result and sending to the name node. Okay, so this is all task is basically split into the block, and you will get the result on the one complete result. Okay, and this is the functionality is basically means doing by the name node here. So MapReduce job process input split. Input split is basically splitting the your file into the logical organization of blocks. We will see how these blocks will be organized, and this every input split. This every input split basically are processed by the one mapper here. So okay. So local processing preferred here. Local processing means there are one local address, local racks data basically selecting for this one mapper, and this mapper basically using for connecting the stars. Next is, you can see here, that is input splitting is very intelligent way, working in the very intelligent way. That is means whatever the file format we have, that will be automatically detecting the file format, and depend upon the file format that will be intelligent dividing the blocks. Okay, like file format we are talking about, like we have the XML file, we have the JSON file, we have the zip compressed text files we have. So it may be these file may not be for this task. So we need to enforce for sequentially read. Okay, for one mapper. So we need to avoid these tasks like XML, JSON file, compressed text file. So this may be not helpful. So we need to enforce this file we store into the sequentially. So that is the mapping data blocks into the split input split. You can see here that is suppose that this is the total size is 513 MB, and you can see here that is creating into the ABCDE part. And you can see here that is physical HDFS is creating 128 blocks here, data blocks. And this is the physical HDFS presentation. And this complete input spread will be divided into the data blocks boundary. And this is called the logical map reduce. We have seen the logical map reduce that is storing with the task tracker. So that is means that is logically that is stored into the 1 8 boundaries. Next block will be stored in next 8 boundaries, same way into the and so on, and last will be stored into 1 1. Okay, and you can see here that is file are processed into the input spread, and which basically are the composed of the record, and this mapper will be used for the key value pairs here and map reduce. So key value pairs will be calculating here, and list of these key value pairs is updating by the K2 V2 here. So we will see how K1 V1. So suppose that that K1 V1 is suppose that in one file is written that is you can see here that is written as that is a big data. Big data is a very fast processing. So big data is one calculating is here 1 1. Another one is written as cloud data. Cloud data is very fast processing. The fast processing is appearing very 2 times. Data is appearing 2 times, so it will be updated into the K2 one. So reducer will be used for this. Reducer will be means that is short and shuffle will be run here, and this all the pair will be reduced to how many total number of how many times that will be data will be there, how many times will be fast processing will be there. So that will be updated finally, and that will be replaced uh, to result one. So sequence of writing to data to SDFS. So sequence of writing means how the data basically start to writing on SDFS. So you can see here, I already told you this example. So if you are not able to visualize, so you can see here that is, suppose the client want to say that I want to write this number of file txt, and that this file basically contain the 3 blocks. Okay, so file txt I want to write, and name node will be saying that yes, you can write the file on 156 data node. So 1 5 and 6 data nodes you can write the file. So client use this information and write the file on this one 1 5 and 6. Okay, and again next time another client will be accessing same thing, means want to write another file. So they will again contact with the name node will be say that yes, you can write this file on the 5 6 node. If suppose only 2 blocks are there, so you can write on the 1 5 or 5 6. Okay, so this is cycle is repeating again and again. You can see here that is writing data to SDFS, and this means finally whenever the writing is done, okay, means this client is writing ABC, and name node introduce this data nodes where you can write this blocks 156. So client will be able to write this data. Suppose this black line is basically explaining this, is writing this data is basically into this node, and this finally this data will be creating in the 5 and as well as the 6 node. Okay, so it means that is ready, that first time that will be write to data 1 in the 1 node, and it will be writing on the another rack. So the rack information is basically stored here. So data node having this rack information, so it will be stored into the 5 node and another node also. So you can see here that is name node is basically is picking this 2 data nodes from the same rack here, and 1 from the another rack for storing this file. Okay, and you can see here that is whatever the replica. Okay, whatever the replica of this file will be also be created here. So we will see how this will be creating here. So name node also having the rake awareness algorithm. Rake awareness algorithm having the, this is a means not storing onto the particular one rack and store the data onto another rack also. Okay, So that means that is rack awarening. This means how many nodes in rack 1 is basically incorporate, the name node having this information, and how many nodes are incorporate in the rack 5. Okay. This is a replication scenario, replication pipeline. We have already talked in previous introduction thing. So multi-blocks replication pipeline is used by this Hadoop architecture. So you can see here that is ABC file is basically write with this client. Okay, and there are three racks are there: rack 1, rack 4, rack 5. So that AB, suppose this file is creating writing by this switch, and you can see here that is block A is basically stored here. Okay, block C will be stored here. So you can see here right now it's a block A. So whenever the block A is stored here, so automatically this data node will be create the replica. Okay, of this block A. You can see here this one line is going this one, and this replica will be stored here. Okay, and due to the loss, due to the any loss, if suppose rack 1 is not able to work, so that means our data will be available on this rack 4. Okay, block 1 we can access the from the rack 4. Okay, and you can see here that is again this data node again creating the uh, replica or replica of whatever they have stored. Okay, same way whenever we have creating this block B, it is also stored in somewhere in the rack 5 here. Okay, so all things means that is means we having the capability, that is means we are the replication of data is basically in which that is fast access, even the due to the loss to you even to access your data. As Dual's Files reading operation, you can see here that is basically that is finally we have stored the data and writes our data onto the machines, onto the racks. And right now we need to read our data. So reading operation is basically same way we want to read the results of a particular file, whatever the processing we have done. So client will be asked, because client doesn't not having the address, is not having the address in which that particularly is result is basically finally compute. But Namnode is having the capability to know that yes, this file computation final result will be available on how many racks, because some due to the some error it may be chances this rack is not working or some data nodes is not working, so another node may be having this data. So it will be asked this, tell me the block location of result txt. That will be checked by the NAM node. Yes, this result is available on rack 156. So it will be available on block wise. So block 1, block A will be available on uh, data node on 1, 5, and 6. Okay, block B is available on 1, 2, and 8. Okay, and block C will be available on 5, 8, and 9. So this information will be passed to client, and the client finally know that this data is finally is incorporate, and this final result is basically you can read by the sequentially. Okay. This is the name node and high availability. Just a minute. So name node and high availability, you can see here name node and high availability of name node, in which you can see here that is uh, uh, whatever the name node is available here, it capturing the data node continuously, means capturing means that is checking that this, yes, the data node is connected or not. How this is basically done, this is means sending the heartbeat. Heartbeat means we can say that this is the ping signal simply. and this is the every 10th heartbeat, the block will be report here. Okay, so that means every 10th heartbeat, that block is basically reported to the name node, and name node build this metadata of all the blocks and whatever the report is giving by the blocks here. So metadata will be creating yes this file is working or not, and finally this will be stored into the file system. So this data nodes will be saying that yes, I have the blocks of AC. So name node yes know that yes, data node 1 having the blocks of AC, data node having the AC, and data node 3 is having the AC. Due to the any connectivity, suppose that data node 3 is not working, so that will be automatically update here. That is means data node is not working. So that DN1 and DN2 is basically having this data. Okay. This is the scenario in previous scenario in which suppose that this replica missing. So that means data node is not 3 is not working. So it is automatically deleted here from the metadata. So from the REC 5, you can see a data node 3 is not working here. So REC awareness algorithm is working here, and they can see that that means data node 3 is not connecting here. So due to the missing heartbeat, so signal is lost. So we can say that this data node is not having this characteristic. So we can change our address here. Okay. So this is the overall Hadoop. Hadoop limitation, Hadoop version 1 limitations are, it is not suitable for the batch processing, whatever the batch task we are giving here in previous scenario. Or suppose we want to select some task on the batch wise. So it is not suitable. It is not suitable to real-time data processing sometimes. For some application, it may be suitable, and some application it not be suitable. Okay. So, this is the one limitation, and single point failure of name node. So we have the secondary name node, but that is storing for the backup purpose. But if suppose due to the name node is failed, so whatever the data connection lost or information may be already lost here. And Hadoop one is not supposing the multi-tenancy supports. So means it not able to capturing the information multiple form, and means connection if lost, so it will not able to work here. So if suppose that is horizontally scalability, means that is scalable by uniform way. So that Hadoop version 1 again not able to support this one. Okay. And this is only run the MapReduce jobs, and that's using the slot concept for allocating the resource. So sometimes slot we have seen that 1 to 8 slots we have. So whatever the slots is occupied, so it may be some task may be not able to schedule in this time. Okay. So that means slot concept is very not supporting sometimes in the resource allocation properly. So Hadoop version 2 is a real-time interactive processing of event, and this is the basically real-time as well as the, we can say that very interactive way that can be used, and that is basically Hadoop version 2 is basically Yarn, and that is yet another resource negotiator name is, and support for classical MapReduce as well as the previous MapReduce functionality is supporting by the version 2, and support for NFS access to and HDFS means network file system you can access, and you can access the HDFS even. Okay, so that is all the compatibility of Hadoop version will be applicable in Hadoop version 2, and this is highly available. Federation and a snapshot of the HDFS is basically given by the Hadoop 2. So you can see here that is Yarn system architecture. Some modification is done by the in this. And previously we have name node and data node. Right now we have the resource manager for managing the resource. Okay. So client having the access to resource manager, and resource manager basically are the having the manage the all the resources. Okay, and this resource manager basically is connecting by the node manager. Okay, so previously we have the data node. So right now, this name node is basically previously right now. Then this is replacing by the resource manager, and node manager is basically connecting by the this resource manager. What is this node manager? Node manager is basically are the whatever the suppose having the connectivity means having the processing power. So node manager having on resource management, like they are node one, this node manager one having the suppose storage around 10 GB and computing power around 10 GB. Okay, and this is the storage for around 2 GB and computing power around 2 GB. This is around 1 GB and a storage power of 1 GB. So this is all information will be passed to the node manager here, and node manager will be having the container. Okay, an application master. What this means, application master and container. Suppose that if container is basically contain the some resources. Okay, so this resources information will be stored by the node manager, and application master is basically suppose that if you are running the word count application, so it will create the one application master. Okay, and application master will be create the this application master will be creating the information to resource manager, means whatever the word count will be running here, so it will be going to the resource manager. Yes, this word count is basically running onto the this node one application. Okay, and this container will create this application master. So you can see here that is container is creating one application master blue one to node one to another node, and this information will be passed to the resource manager. Okay, same way you can see here this application master pink one is creating the one container. From this container is creating this application master, and to another container also creating this application master, and information passed to the resource manager. So due to the any failure, this what why this happening here? Due to the any failure, this information is available to resource manager. All the information is available to resource manager. Overall, that can be handle this resources. System architecture, you can see we have seen that Yarn modelizer job tracker functionality, and previously job tracker functionality we have two task tracker. Now it is providing the resource management as well as by the job tracker, and job scheduling and execution inclusive monitoring also be provided into the job tracker here. Okay, and for the computation framework, data computation framework, it is also providing the this functionality with using the container. Okay, so container use application used for execution here, and this container basically used for application, whatever the application will be executed by the container, and whatever the resources need for execution that will be provided by the container as well as will be resource manager. Resource manager component is a global one, and that is having the characteristic of partitioning the resources. Means there are some parts to be uh, one uh, one node manager, or it may be scheduled some application also. So this partition resources will be scheduled under one application of node manager and node manager 2 and node manager 3. It is also be able to schedule the scheduler of resources, means that may be distribute among the different application. Okay, so how this resources will be distributed, how this resources will be incorporated, will be all the will be working in the resource manager here. And application manager is accept the whatever the jobs and negotiate execution of application master. So this is the overall resource manager is very powerful here for calculating this. This is the Hadoop ecosystem component. This is already we have talked in previous first slide. So you can see here that is basically is the pillar in which our Hadoop is basically working. Like we have the for calculating, there are all tools. Okay, so you can see here that HDFS is there, Yarn cluster resource management is supporting by the Yarn, MapReduce. So data processing is supporting by the MapReduce. If suppose you want to use the machine learning, so even the machine learning you can use for the here for the MapReduce, and Mahout is one tool, and Drill and Analytics basically used for this one. Okay, so if you need to use the management and monitoring some management and monitoring of these your files, so Apache Ambient is basically there. Okay, workflow is there for OZ, so you can handle by the workflow by the OZ tool. And data collection means how this where you are collecting your data in Hadoop system is by the scoop. So that is there all overall. This is a one Hadoop ecosystem that is continuously changing because there are new tools is incorporating. So query handling is, you can see Hive is there and Pig is there. So scripting writing. So all this thing available in one scenario, and you can use this in very well form. Now you can see here that is MapReduce programming model. We have seen this previously, that is Hadoop 1, Hadoop version 2 file system. And this overall this Hadoop is basically is for the storage purpose, and the calculation is basically done by the MapReduce. So MapReduce is parallel processing. So that is the platform for reliable and scalable parallel computing. And this MapReduce is basically used for distributed and parallel environment. Okay, so you can use this MapReduce even for the distributed environment, in the parallel computing environment even. So the you can see here that is Google file system, Hadoop file system is a work on the distributed one. Okay, so Hadoop file system and Google file system is used the I don't know what the distributed file systems. Or this MapReduce is inspired from the two tasks, that is map and reduce operation. So that is basically this map and reduce operation is basically used in the functional programming like Lisp, or this is basically handling the giving the input of set of key value pairs here, and user supplies two function here, and this map, and that is kv, we have seen that, and list of k1 v1 is basically updated by this thing. And reduce is basically finally whenever shuffle and short is produced here, and reduce will be whatever the k1 and list of v1 value is basically incorporated into the v2 final. Okay, so this is final output will be generating the whatever the set of values, key value with the whatever the pairs will be updated here. Okay, so this MapReduce you can see here, that is we can take one example here for introducing this one. So you can see here that is input file is there, or this apple, orange, mango, orange, grapes, plum, and another file is apple, plum, mango, apple, plums is there. So you can see here that is first is basically each line basically is passed to the individual mapper instance. So this one line is pass here, another line is pass here, one line is pass here, another line is pass here. Now mapper will be used checking the how many times this word is basically appearing. Suppose this word count application we are running. So map key value is splitting this into the number of count, so that key one value pairs. So that the key value pairs will be here, there means how many times that will be appearing. So first is apple is one, orange is one, mango is one. if suppose that this apple, orange, mango, instead of this is apple, apple, mango. Okay, so it will be arranging into the 1-1 count initially. Clear? So the same thing you can see here, that is apple, apple, plum is coming. So apple, apple, plum is coming into the 1 form. Mapper will be counting 1-1 at a time here. Now from this task, this all thing will be passed to the sort and shuffle. So you can see this connection is to pass to the all these shuffle and sort. So whatever the all apple, how many times this apple is appearing, it will be counting the apple one section, and how many times this grape is appearing, that is count into the one section of grape. How many times this mango is appearing in this, so you can see here there is 2 times. So mango one is appearing this block, and same way this orange is appearing in this one, and same way in plum. Finally, after this, the reduced key value pair is counting this, how many times that will be appear. So that means this is we are reducing. So that means apple is 4-1, grape is 1, and mango is 2, orange is 2, and plum is 3. And final result is output given by the reduced pair here. How many times this key and whatever the value will be appear. Clear? So that means we are explaining this input key value pairs. So that same way it is running here. So key value pairs means key is apple and value is 1 here. So instant first time that will be map 1 and 1 at a time, and intermediate key value pair is creating here from this giving by the this overall one line. Okay. And finally, intermediate key value pairs will be incorporated to key value groups. So groups means the shuffle and short will be running here. So apple, how many times this apple appear? Plum, how many times this plum is appear? And finally, this output key value pair reduced. So apple is appearing 4 times, plum is appearing 2 times, orange is appearing 2 times. Clear? So this is the output key value pairs. Clear? So this is the MapReduce, complete MapReduce example. And this is the execution of MapReduce. Actually, we have seen the example of MapReduce, but how actually behind the system this is running. So in the terms of master and slave and the distributed file system, you will see here that is user program will be start here. Okay. So user program will be create one child process here. So that child process is creating in the master, and as well as into the connecting with this worker here. So there are 2 phases. We are dividing into this MapReduce into 2 phases. One is map task, means key value pair, fetching the key value pair. Another one is reduce task. Reduce task means complete output fetching. And whatever the sort and shuffle is basically working in the reduce phase. Okay. So the master will be first accessing this information. Yes, they want to perform this task. So master will be checking how many workers they have. Okay, for the map as well as this one mapper side and well as the reducer side. So first the input file system will be divided. Input file system will be divided into the different document, and this document will be provided to the worker here. Okay, all the worker will be access this document, and worker will be providing the map task and whatever the map functionality, that means single key value pair finding here. So that means providing to intermediate files. Okay, finally intermediate files accessing by the reduce phase, and reduce phase will be applying the short and shuffle and calculating the output file 1 and output file 2 of these of all input files. Okay, clear? So because this is the worker, 2 workers are there, so finally it will be incorporated into one output file, but this is the worker 1 file and worker 2 file. So you can see here that is worker is basically having the 3 mapper, and there are 2 reducer. Okay, so this is the one limitation, or we can say one characteristics of MapReduce, that is reducer is always less than with compared to mapper. Okay, reducer is always less than is compared to the mapper here. So this is the map reduce execution overview. Right now, you can see a distributed execution overview. Distributed execution overview is the same thing previously we have seen. So how basically is locally this is happening here. So locally is basically input data from the distributed file system is split into the blocks, split 0, split 1. And this is worker is basically reading this data. You can see here. And finally, whatever the functionality is, mapper is basically worker is there and writing on the local write. Okay, local write means that is intermediate write. Please mute yourself. Some echo will be generating here. Okay. And finally, remote files read this sort and reading this data and applying the sorting, and finally write operation will be performing here. Okay. This is the map reduce execution. One example you can see here, that is one code of the count word frequency last text. So that is one code of how this mapper is working here, how this reducer is working here. So this is a very simplest example of key pair values for calculating in this. Okay. This is same thing is basically in the form of program and algorithm. I'm limiting right now. So this is the phase of MapReduce execution. So phases of MapReduce execution are one jar file, distributed core is there, jar file is there, and that whenever the jar file we have, we need to determine the blocks and file split, assign a mapper to split in those slots files, and map basically running here for local map function, invoke the local map function, and finally we have shuffle, sort by the key and exchange the data. Shuffle, sort by the key and exchange the data. Okay. And finally combine the perform the local reduction by the key here. Okay. So this is the combining on the reducer side, and partitioning key spaces among the reducer with the hashing key is basically used here. Okay. So you can see here that the execution of MapReduce on HDFS is basically working in this scenario. Node 1 and node 2 having the different key pair, and key pair value is mapper running here. Then finally intermediate key value pair is combiner here, and finally substitute the intermediate key value pairs for partitioning purpose. Okay, and this is going to this one node 2, and finally partitioning key value pair is going to this one. This is called the shuffle process. Okay. So this is intermediate key value pair exchange by the all nodes. So because all nodes basically are doing this task, because due to the any node is basically is not able to do functioning, so it may be available on the second node as well as. Okay. So steps of execution of MapReduce on the Hadoop. So we have already seen that both functionality means that is Hadoop as well as the MapReduce. So you can right now able to imagine a scenario in which how this MapReduce basically work on the Hadoop. Okay. So because I think right now you are able to understand these two functionality, and you can easily predict this. Yes, what will be the role of job tracker whenever this MapReduce will be working? What will the role of task tracker whenever the MapReduce task will be working on this Hadoop? Okay. So for more explanation, this is the point-wise, step-wise execution here is written here. So you can imagine this thing like client first submit the job to the job tracker. Okay, that job tracker will be track this job first, and job tracker is basically next time is want to identify the location of data and where's the data basically here, and this data basically providing by the name node. Okay, means location of this data is basically providing by the name node. And finally, job tracker start the or we can say second, third phase, that is start the task tracker, locate the task tracker, and use and task tracker basically used to logical CPU. On logical CPU basically are looking for the how many slots. That means whenever talking about the logical CPU, so that will be checked the how many slots uh, that is close to data is basically having. Okay, so this is the three steps first. Now fourth one is job taker start the task on the task tracker nodes. Okay, so that one task will be start on the task tracker nodes, and that will be monitoring the task tracker nodes, that means functioning or not. Okay, means monitoring is will be done by the, as you know, the 10th heartbeat. So heartbeat signal are missed, so we can say that that is reschedule will be performed by the task trigger. If suppose that any one node is not working, so that will be rescheduled the task trigger by the task trigger. And this whatever the fail information, if suppose due to the node is not working, a task is failed, so this failed information also be transferred to the job tracker, because of job tracker able to identify, yes, right now this is not task is not completed. And the job tracker constantly update its status to the name node. Okay, for the client, means that is means to the name node, means that is for the client, yes, your job is running, how much time is left, how much time will be this file will be, the final result will be incorporated to you. So that is, you can see a data processing on map. So map task, how many times does refund appear in the file text, so job tracker will be using here. So name node giving the information of this one job tracker, and so job tracker will be tracked, yes, map task is running in data 1, data 5, and data 9. So it will be capturing here. So count how many times this refund is appearing, 3, 0, and 1, and it will be total is file text will be incorporated to this one. Okay. Whenever the data is not local, so that means if data is not local, means data is not stored into the one location. So it may be capturing, job tracker tries to select the node in the same race on the data, and name node Ray Kubernetes algorithm running here and providing the exact location of this data. Okay, so this so that you can see here that no map task is left, so it will be providing to this node block A here to data node 1. Okay, so in rack 1 you can see here that is data node 2 is providing the A to data node 1 here, and this information also passed to the job tracker and name node also. Means name node is capturing this information and passing to the job tracker, as well as in this passing to the client here. Same way for the map phase, the reduce phase is also working in the data processing. So the job tracker basically use the reduce task here, and the client is basically want to access this data final result. So that means HDFS will be running here for reduce task, and they're having the blocks of data, like A, B, C is block of data is having, and finally how many times this reduce is basically appearing, that will be going to by the reduce task, and job tracker will be sum up this data, and finally result will be uh, performing and displaying on the client side. This is the life cycle of MapReduce job by the coding wise. Okay, map function will be, you can see here, this map function is in Java file. This is the another reduce function is creating in the Java file, and this is the run this program of MapReduce function. This is online is available. This complete form is available online. This is the life cycle of MapReduce job file, means how this files is dividing. So input file is a split. Map wave 1 will be running here. Map 2 will be running here. Reduce wave 1 and reduce wave 2 will be running sequentially. Okay, with this limit of time. This is the component of Hadoop in MapReduce workflow. So job tracker, how many things having the job tracker? This is the master one. So accept the MR MapReduce job, assigning task to worker, monitoring the task, handle the failures here. We have already seen this thing. And client is getting various status information and submitting the jobs here. And task tracker worker is basically using the running the tasks, run the map and reduce tasks, manage the intermediate output, and a separate process run and map function will be creating by the task here. This is the job submission we have already talked here. So I'm eliminating right now these things. And this is a complete information is already given here. So right now I'm talking about the research research in MapReduce, that is enhancing the basically MapReduce. We have seen that. So there are many direction researches going on MapReduce. Some of the going on the physical as well as some is going on the application one. Okay. So first research direction is I want to tell about this enhancing the MapReduce performance. That one is research is going continuously on by collection of related data and implementing efficient iterative algorithm for managing the skew of data. Okay, means skew of data means data may be not available and data may be lost, or means if suppose that this one node is not able to capture performing this data. Okay, because that is slow. Okay, suppose that as you know that is one map task is running, one reduce task is running. Suppose that our data is dividing into three data nodes, and these data node individual is running individual task. One block having on data one, B block having on the data two, and C is having on the data three. Suppose that, and data one having the more capability, so that will be execute fast. Data two having the more capability, that will be execute the fast. Now data three is not having the this match capacity, that will be execute slow. So whatever that is computed and given to the name node, so that will be suffered due to this data node. Okay, so that is there are some issues in this map reviews. So there are research in MapReduce going on by the integrating database with the MapReduce. So you can integrate the old database, new database as well with the MapReduce and functionality analysis, integrating the indexing capability of MapReduce. So indexing capability is given by the MapReduce, means increasing in the how to store and index this your data and using the MapReduce. Machine learning even you can use here. So there are some tools is also already here, or some area in which data is already working here. Empower Hadoop by careful data organization. So the MapReduce empowered by the Hadoop, there are data organized is not very much, so we can empower by the organize the data into the appropriate form. So we can use some other platform, other tools for this purpose. So there are some researches going. And enrichment of MapReduce with the data warehouse capability. Right now, there are two separate parts. Data warehouse and MapReduce is separate parts. So we can, in combining this data warehouse with the MapReduce, and you can analysis the some prediction over. You can even done with the data warehouse. Okay, data. And finally, the SKU management and MapReduce. I know this one. This is all about of lecture. If you need to ask any questions, most welcome.
Thank you so much sir, for your elaborative and nice session. Very thankful to you, and we are very